家乡的波霜，窗前的月光，都照亮心底某个地方。有人用思念酿断俗世行，流淌过1000年，恋恋难忘。你有绿树红墙，替我遮风霜，也有草长白云白，吹到长城长。天水煮小巷，早上老火汤，再加3分时光，坐在门前慢慢尝。人间烟火山河浩荡，清风过大江，水路弯弯连海浪，两岸千里的花香。你爱的人啊，记得你最好模样，你是大宝的忠贞，是心之所向。时代滔滔向前，温柔而勇往，留不我梦中的你，花开遍山岗，蹒跚着成长，离开又回望。你是年也是乡，是童年的一个档。人间烟火山河浩荡，大雪落夕阳，午夜钟声是响，一缕团圆的泪光。你爱的人啊，永远放你在心上，就算已白发苍苍，也别泪光。人间烟火山河浩荡，你任我去闯，多少个还会东望，最远最近是家乡。我爱的你啊，泪落千年的时候，为这小小的歌我靠近你月光。要用尽啊，用一生才懂寻常。我与你啊，爱当时擦肩相望，这一刻忘了奔忙，也忘了沧桑。爱的人还在身旁，落叶又回到枝头上。哇 Hello Simon. Welcome to another day. I woke up and decided to torture myself. Let's jump straight into the question. Triple sum close to the target, medium difficulty. Given the array of unsorted numbers and the target number, find a triplet in the array whose sum is as close to the target number as possible. Return the sum of the triplets. If there are more than one such triplets, return the sum of the triplet with the smallest sum. If there are more than one triplet. So input is this, target is 3, output is 2. Wait, what do you mean output 2? Find a triplet in the array whose sum is closest to the target number. Return the sum of the triplets. Return the sum of the triplet. Oh, okay. So the triplet is minus 1, 0, 3. Has a sum of 2. Oh, so even though this number add together does not equal to 3, we think that this range is the closest. Oops. Is the closest to 3? So you return 2. There are two triplets with distance of 1. So minus 1, 0, 3, minus 1, 2, 3. Between these two triplets, the correct answer would be return the sum with the smallest sum. Smallest sum. Example, this target is 1, output is 0. This has the closest to the target. Target 100. Output 3. 1 on 1 is closest. Target is 5. There are two triplets with distance 1. 1, 2, 3, 1, 0, 3. Between the two, the correct answer will be 1, 1, 2. As it's sum of 4. Another one is sum of 6. Because of the requirement. Okay. Okay, I'm gonna code the first part first. Well, actually, let me see. Yeah, I'm gonna code the first part first. A triplet. So the issue here is like they want a triplet that closest to the target. We can do a pointer. So we're gonna loops I equal to 0, I less than array dot length. I plus plus. We're gonna iterate through the entire array. This gives us a guarantee. Big O notation of n. N is the length of the array. Because we are looking for triplets, we can set the targets. So for each iteration, let left equal to I plus 1. And then right would be array dot length minus 1. And while left is less than right. Or left smallest. Smallest. We need to set a smallest number. I need to preset the smallest number. I can set it to, because they are looking for sum, we can do array 0 plus array 1 plus array 2. If the smallest is this one, then we don't care, then the smallest. But since we are comparing these anyway, so this preset is fine. And then sum, right? Sum is equal to array left. No, array high, the current I, plus array left plus array right. We're looking for target sum. Closest to target sum. Oh, shouldn't be smallest, closest. Sum is declared, but it's never used. It's used. What are you talking about? And then we do a sum. And then we're looking for the target. What website is this? It's on top. Here. Sum is these, the first triplets, and then we're looking for target sum. If sum is inside method, but you're not calling method yet. Oh hey, easy. Oh, you play Yu-Gi-Oh and you also code? Nice. But this shouldn't affect, right? Even though it says it's not defined. Not used. What we want to do is, actually, we can just do the sum here. You basic Python? Okay. Python is cool. It's we're looking for absolute value. We're looking for closest, so we don't care about how much difference. Cause I think that, well, the target sum, the target could be a negative value, right? So we're only looking for the closest. Math absolute target sum minus sum. If this is less than the closest, well, then we found a new closest, right? So we found a new closest, so closest will be equal to let's see. I don't need to calculate this multiple times. Sum and just call it temp. Temp is equal to math absolute target sum minus sum. And if temp is less than closest, that closest is equal to temp. Right? This satisfies. I'm not doing this yet, but let's just code this the first part correct. And then I just return the closest. Right, this should let's see, run. Oh, even a loop because I'm not incrementing it. And then we left plus and then right minus run. Output is 1, expectation is 2. Actually, can it be a negative number? Some can be a negative number. So I don't want to do absolute here. Closest. I want to do here math absolute temp. So 10 can be at closest. But the absolute here just makes the calculation easier. This will still be wrong. Okay. So let's see. Negative 1, 0, and 3. The first iteration of the negative 1, 0, and 3. Well, left is less than right. Right, so negative 1 plus 0 plus 3 is 2. So sum is 2. Temp is equal to the target number is 3. So 3 minus 2 will be 1. Oh, okay. This should equal to sum. Run again. Nani? So we know sum is 2 now. Temp is equal to 3 minus 2, which is 1. Math absolute 1. The closest initialize is 1, 0, 2. This is a 1. Closest is 1. Oh, okay. Yeah, the initial value is wrong. Okay, initialize the value. JavaScript initialize negative. My closest is still wrong. Closest. This doesn't matter. Still, it doesn't matter here. But okay, yeah. I want to initialize a big negative number. And this definition is not good. Closest should be song. And we're looking for target marathon. I just need to initialize a value that I'm sure that it's gonna be not the first one. What do you guys do in this case? You can initialize big none. Ooh, non-negative infinity, that's a thing. 마치대. Non-infinity. Negative infinity, this value is less than the largest number that can be represented in JavaScript. A value that's less than the largest negative number. So, in that case, this comparison will be not a number then. Yeah, it's no, because we're comparing not a number. None dots. Maximum. Is there a maximum main value? Max value? Max value or negative non-to max value? It should be right. Okay. Output. Okay, we call the smallest negative number. Oh, I don't care about negative here because I'm comparing absolute. Oh yeah, so run again. Accept it. Yes. Okay. Submit. Submit is obviously going to be wrong because I'm not taking care of the second condition. Oh no, let's look at the second condition. If they are the same, we're looking for if they are the same, we're looking for smaller sum. If difference is the same, we're looking for smaller sum. Okay. So same. Let's just. From this, you can tell I have no naming sense. And then we're gonna set same equal to 10. Right. So next time, else if we find a math absolute value is equal to closest, right? Then we look at and if we're looking for the smallest sum. if the difference is the same, if the difference is same, then the sum is the same. I mean, 10 is the same. Is the same. If they're the same, then we compare the sum. Okay, if they're the same, then if closest is, in this case, is 4. If closest is greater than the current sum, then we want the new sum. If closest is greater than the current sum. Wait, what happened to your comments? Why did your comments disappear? If closest is greater than sum, then we want a smaller sum. So closest equal to sum. Closest. I don't need the 10 thing. I don't need the same thing. So if I run this again, this should be the same. I run this again. -2. We expect 0. If 10 is equal to closest, so we found 2 triplets that's closest to our target number. And if that's the case, we want a smaller sum. And sum is less than current closest. Then closest will be the new sum. Wait, what did I? Right, this should be fine. Right. Logically, it makes all the sense. Okay, 3, minus 1, 2. We're looking for 1. So this is 2. It is minus 2. Sum is -2. Oh, sum is -2. Wait. Technically, -2 is less than 0. You want the return the triplet with smaller sum. Return the triplet with smaller sum. This is correct. What do you mean? -2 is less than 0. So -2 should be the smaller sum. No? What am I missing? So this is -4 plus 2 -2 or -2 to 1. -2 to 1 is distance of 3. Okay. 10 is equal to -2 to 1. Target sound is 1 minus. Oh, minus. Okay. Minus. Wait, I don't have a minus. Sound is -2. So target sound is 1 minus -2, which is 3. Right? If math absolute 10 is less than. So this first one will be less for sure. So closest is now -2, and then we move next. Oh, there's no move next. No minus, just plus. Run. Wait, hold on. We look at this value, look at this value. If I only do right plus, then I look at this value, look at this value. Yeah, left. I want to look at all the values. So hopefully somehow fine now. I look at this value, look at this value. Next, I move here. And look at this value, Next, I move here. They'll be the same, so this would not trigger it. So comparison 1, 0, 3, 1, 0, 3, and then 1, 2, 3, 1, 2, 3, negative 1, 2, 3, and then 0, 2, 3, 0, 2, 3. If I go over negative 2, 3, so that's all the value that compared. So this is correct. Like, this only has combination of 3. And then math, 10 is this. Oh, we're looking for closest number, not that smart. Okay. Math dot, is that this? Math dot this. Actually, no. Target sum, this should still be the... So first iteration would be 2. And the target sum is 3. So 2, expect should be 2. 2, 10 is equal to 1. Difference, so by default this sets to 1. And next one we look at is negative 1 and 2, 3. Negative 1 and 2, 3. Is equal to 4. So 10 is equal to target minus sum. Target sum minus sum, which is 1. Which is same as the other number. Right, so we look at the diff. They should be the same. And then we look at the sum. This is 4 and this is 2. So sum is the sum of this is not less than closest. So this skips. This is correct. Right, and then 2 and 3. 2 and 3 is 5. 5 we're looking for 3. So target sum 3. 3 minus 5 is 2. Like mathematics absolute is 2, right? 2 compared to closest. Closest currently is 1. So 2 compared to closest. Math temp. 2 is no less than 1. So closest should still be 2. Temps. And then closest. Well, the current closest is a giant big number, so this is fine. Target sum is 1. Target sum is... Wait. Temp difference is 1, right? Difference is 1. So this should be The closest should be set to 2. This is correct. And closest should be set to 4. Wait, what didn't it... 2 and 3. 2 and 3, we're looking at -2 and 4. Wait, how did closest become negative? 10 is -2. Closest became 4. Oh, this combines 4. No, it should not be 4. Did I mess up something?我等等就要考计算理论，看到你直播。哦，那你就应该不要看直播了，因为我的编程很烂。Okay, this one updated to this is correct. The next one is -1. Difference between -1 and difference between -1 and the target number is 3. So target sum -1. Target sum -1. This is also 1. I said both of them are 1. Oh, this is compared to sum. Why am I comparing this? Oh, this is wrong. Okay. If the difference oh, that's why. So I will set a diff is equal to tenths. So if the current temp Dubai, なんで? The first one is 1. 1 target, 3 is 2 difference. Ah, my brain is not working today. Sum minus target sum. One? No, that's We're only looking for difference, so it doesn't matter which way. Okay, so first thing we're looking at is these. Right. This one, the sum is negative. Wait, the sum is 2. The difference is 1. And then we compare this one with the closest. So obviously, the closest, this will be less than the closest. So the new closest is 1. But the new closest is 2. Oh, because I keep resetting this. Oh, okay. I'm comparing 10 is the difference, the new difference. So this one, the sum is 4. 10 difference is -1. And the current closest is 2. Right, so absolute of 1. Oh, I'm comparing to the wrong thing. So absolute 1 less than closest. Ten is the target sum -1. Actually comparing the I should be storing the difference. This number sum is 2. 10 is this. Closest is this. Yeah, I'm not. I know where I got it wrong though. I know where I got it wrong. I just have to be not wrong. So 10 is the difference, right? Oh, we want difference to be. This all should be numped max value. And closest is, we don't care about closest here. There, okay. Because I was comparing, I keep resetting the value because I was comparing the difference between the closest sun. Yeah. So now, in this case, always compared to undefined. Well, this undefined is fine, because... Wait, no, undefined is not fine. We pepper a max value here too. Once. Oh, if we found a close sim, so I should also update the difference. So this now can be shortened to this. So this is the 6 for this case. So the first one should be 4. 4 is here, which update is correct. Process. Oh, sum is 4 too. After that, the sun should be 4. Wait, no, this is a new song, but the closest should be 4. Oh my god. -1, sorry. Sum is -1. 10 is 2. Wait, sum is 2, 10 is 1. The difference is 1. You're looking... Wait. We're looking at 5. Target is 5. So Tally sense 5. 5 minus 2. So 10 is 3. This gets updated to 3. That's correct. Difference is 3. And then the next one is sum. Wait, crosses. It's correct, so this should be updated too. Wait, no, yeah, it is updated too. I was looking at the wrong number. Don't. Just so it's easier to read. Oh, because that's why this number too big. There are too many big numbers. If I run this, then we look at smaller value. 6. 006. 006. Sum is 6. The difference is -1. And we are comparing to the absolute value. So it's 1. Oh, we compare to the absolute value. We are comparing to the absolute value. So both of them should be comparing to absolute value. Run. Okay. Next. Well, it doesn't matter if it's absolute value or not. So if 10 is math absolute value of these two, why we always compare these two. Yeah, okay, we stuck at the same one, so that's fine. We simplified it. Simplified it and still works previously, so that's progress. Current one is this. Sum is that. Sum is 2. 10 is 1. Closest is big giant numbers. Like, and diff. Oh, there's no diff. There's no initial diff. Right, initial diff is giant number. Doesn't matter. So 10 is always gonna be less than giant number. Right, sum is this compared to this. This must be less than. So update it. This should be this, and this should be this. That's correct. And then the new one is this, and then the difference is this. It's not different, so still 6. Still 6, that's correct. Next is okay. 2 and 6. Okay, this is where it should be updated. 2 and 0, 2 and 6. Wait, am I looking at the same one? 0, 0, 0, 0, 0, 0, 1, 1, 2. 1, 1, 1, 2. Okay, with special cases, we're looking at 1, 1, 1, 2. Oh, there's no 1, 1, 1, 2. Okay, that's why. We're not comparing to the full value. So 1, 1, 2. 1, 1, 2. Okay, the loop is we look at this, we look at this, we look at this, we look at this, this. So these two will always be fixed. So we look at this, and next is going here. This is also fixed. We look at this, and next should be here. And this, we look at these two. And next, oh, because this is always fixed. So we missed out 1, 1, 1. We missed out the middle one here. How do I not miss the middle one? What if I do right minus minus? Accept it? Oh no, now it's correct. Submit. And now it's wrong. So now instead of this, I'm going backwards. This must say 1, 2. Oh, going backwards is now it's also wrong. Because going backwards means the next one will be this. And I'm going backwards. I should know this, and then this goes backwards. So I skip out this combination. How do I not skip? I want to look at all possible numbers. Oh, what if I array go to array sort? Oh, what's the sort? Math dot sort. Wait, it should be array dot sort. A B. We're looking at A minus B. If I pre-sort this, now it's correct. If I pre-sort this and then I do this. No, it's not correct. I don't care about police sword, because they're only looking for the sum value. Uh, if I found it closest, I move both. Ah! My brain is not working. That's correct. This following follows the pointer pattern is quite similar to triple sum to 0. We can follow similar approach. Take one wonder. At each step, we will save the difference between the triplets and target number, so that in the end, we can return the triplet the closest one. Here the detail workflow. Initially, the method checks whether the input array is null. Oh, I'm not checking null. Or length is less than 3. That method returns. I haven't got to this point yet, but okay. The input array is then sorted into ascending order. Okay, I did that. The smallest number is integer max value. Okay, I did that. Wait, I'm not using integer. Number. Integer. I don't think that has any. Wait, what's the thing? Integer max value? Integer down max value, integer the max value. Run this. Integer is not defined. Yeah, can you lying to me? It's not integer. Num. Which you keep track as smallest one so far. Yeah, that's correct. I have that. The function then iterates array using a for loop. Okay, I did that. Stopping when there's 2 positions from the end of the array. This is because we are always looking for triplets and does not need to consider the last 2 possible in this loop. Does not need to consider last. Oh yeah, that's correct. But this doesn't. This doesn't matter here. This will still be this. Like, this doesn't matter in my case because my next condition takes care. I should. Can I open this? Inside the for loop, 2 pointers left and right. I have that. Left is set to I plus 1, and right is set to array length minus 1. I have that. We start with the while. As long as left is less than right, I have that. Calculate the difference between the target sum and the sum of the numbers in our current position in the array. Target difference. Okay, I have that. I have difference. To see how close the curve. If the target difference is equal to 0, that means sum of current triplet matches the sum and return the target sum immediately as our solve result. Okay. Otherwise, we check if the absolute value, yeah, that is less than the absolute value of the smallest difference. Or if it's equal, then if the target difference is greater than either condition is true, we update the difference with the target difference. I have that. Next, we check if the target difference is greater than 0. If it is, oh, I don't have that. If the target difference is greater than 0, if it is, we increment the left and try increment the. Oh, okay, target difference is right, then we move right. This while loop continues until left right is. Oh, okay. This is correct, but I need to do this conditionally. I just need to do this conditionally, so I don't do the absolute value yet. In fact, I should still do it here. Absolute value of 10 is less than. The absolute value. This condition should still be the same. In this case, it's equal. Because now this is sorted. If we get a 10, that's a negative number. If 10 is less than 0, if we get a 10 is negative number, that means since now it's sorted, if it's negative number, we increment the left pointer because left is the smallest value. And if 10 is greater than 0, then we decrement the biggest value. And otherwise, if 10, I'd like to do it here. If 10 is equal to 0, then we found a pair. So we just return sum. Okay, that's correct. That's raw. Okay. If 10 is less than, we move the left pointer. If 10 is greater than, we move the right pointer. If they are the same, if we found one, then we move both. What about that? Omit? Wrong, okay. Oh, brother. This is correct. This continues is cross. At which point we examine all possible I. The for will continue will have try every possible starting. Once all possible gibbets have been considered, the function returns target sum, smaller sum. Oh. Yeah, in fact, I need to update target sum. Every time, just need to update this difference. I just need to update the difference. Okay. Okay. Right, I have this thing. I is here, we move left, right. And then move left, right, we move left, right. We move left, right. And then when they are... Oh. This doesn't matter here, because this will always trigger. Move left, right. In this case, they can meet in the middle. Okay. We compare this value, the current difference and the previous smallest difference. If it's less than, then we update the closest to the current sum. And then we reset the difference. Sounds about right. Right, so that's what I was doing. This is sorted, pre-sorted. We look at this two. If it's too big, we move left. If it's too small, we move left. We move right. If it's too small, we move left. And then we compare. And then when they meet, we're gonna end the loop here. Then we go to next. And then we do this again. We do this again. This will cross, so end the loop. We go to the next number, compare, right? Next number, compare. I have that. This one, this what my thing is doing. And target difference is greater than smaller difference. Oh, only this part we need to compare the absolute value. Wrong. Still correct. Wrong. Still wrong. God damn it. Okay, we sorted. I have that. This, I have that. Left is this. Right is this. Right is left. Array.length maximum. Array.length. Yeah, I have that. What left and right? Oh, they kind of just combine that. But I had this added together and then this minus that. So that's still fine. This is same. Math. Target difference. Smallest difference. Infinity. Okay. Or if they're the same, and this code can. I don't think this matter. Max value. Yeah, max value. This doesn't matter. They use infinity, but like I have max value, so they should be less than the max value. That will update the difference. Smallest difference equal to target difference. If target difference is greater than 0 plus 1, otherwise we minus 1. That's correct. I have the same thing. If they are the same, then they have the smallest difference. If they're the same, they have the smallest difference. What's target difference is yeah, okay, that's the 10 for me. So they're only updating in my case this 10 different. Yeah, this should be correct, except I keep updating the clauses. In this case I don't really need to update clauses. So cross the difference will be what did I do? Target value difference. With some minus difference. Don't. Still correct? Don't. Still wrong? There's something here that got it wrong. Can I compare here? Don't. Right. Let's see. What's the difference here? Array, pre-solid. Same. Oh, array sort. Can I just update the array? That should not be the case, yeah. Closest. I'm not using closest anymore. So this can fuck off. Run still the same. Left minus 1. Yeah, that's correct. While left is less than right. Equal to. Oh, equal to. Oh, if they're equal. Ah, yeah, okay. I see. So this should be the same. That's to be expected. Right, if the difference is 0, then we return the sum right away. Oh, they return targets, but it's the same. And then if math can write absolute target difference is absolute target difference, and then absolute the previous difference. But the previous difference is offset to math value, so it should always be left then in the initial run. Yeah, that's correct. And if the target difference is equal to that, if the target difference is equal to that, right, I have that. And then the target difference is greater than the... Wait, hold on. Target difference is 10. 10 is greater than the difference. Yeah, I have that. Then we update this value. Yeah, I have that. Right, but if the target difference is greater than 0 with +1, has to be -1. I have that. +1, -1. That's correct. It's the same code, just written differently. So what's wrong here? Target sum -1. Oh, minus difference. This is correct. Why isn't my work not working? Can you see the difference? Wait, what does it do minus? Target, oh yeah, because technically this combined, this minus this combined. So this is fine. This combined, so this minus this combined. We have a new sum, new tenth is the target sum. So the target sum less than the previous biggest difference. But the previous smallest difference. Then we update the smallest difference to the target sum. Absolute value? Oh, what's the difference? Math or absolute? Math or absolute? Math or absolute? Math or absolute? They are the same. They should be the same. If target sum is greater than... Ah! You know what? If the target sum is greater than 0... Oh! I'm stupid! Guys, I'm stupid. Okay, if the difference is greater than 0, we want to... If it's greater than 0... Wait, that shouldn't be the case. Ah! I reversed this. This the only difference here. Nani kore? Ah. if the target difference is greater than 0. Oh, okay. Oh, I see, I see. Oh, shit. You know why? You know why? Because the... So I had it correct. Only thing difference is that this order is reversed. I mean, I was missing this part, and that order was reversed. So 10 is the difference between the target and the sum, right? So if the difference is greater than 0, actually, if I had the sum minus target sum, and then this less than, the previous one would be correct if I reverse this. But because right now, so the target difference is greater than 0, which means the current sum is greater than the target sum, right? If this is greater than the... Wait, alright. If this is... The current sum is less than the target sum, right? The difference is the current sum is less than target sum. So which means the current sum is smaller. So we want to get the smallest number, the closest to the target sum. So if the difference is smaller, then we want to move the smallest number, right? And if the difference is less than 0, which means the current sum is bigger than the target sum. So we want to decrement the biggest number. So write plus first. So I just had this reversed. Yeah. Yeah. I had the right mindset. It just this part, like because usually you think, okay, if it's smaller, like by default, if it's smaller, then we want to move the smallest number. If it's bigger, then we want to move the biggest number, right? That's the mindset. But in this case, it's the target sum minus sum. So, okay, just for demonstration, if I reverse this part, then I can reverse this. It should still be fine. Just to demonstrate. Wrong. No, it's not. If I reverse this part, how is that wrong if I reverse it? 뭔데 다요? Oh, if I reverse it, then I should look at the absolute value. Oh, okay. Why am I hurting myself? My brain is hurting me. My body is hurting me. Okay. Complexity should be n log n because we had a sort in the beginning. So n of log n, yeah. And then space should be n because we're not storing anything. We're only storing one number here. Are you doing homework? This is not homework. If this is homework, then they wouldn't give you the answer right away. I'm just doing coding interview. Next. Wait, I should... I'm gonna end the stream for now. I need to go eat. Bye. 四足，破门而开之间，谦虚半步。一人曾去目，孤行伫立，待得日月当正中。等教问句残花乎？低沟难辨是非，唯有墨鱼之术。盘中人皆得正业乎？而并闻情伤风骨。双折一寸，一方便言和一对对正主，有下人无语。黄雀飞鸟唯有一人卡夫，对月相连，何手之相互，都是在无心日主。横听手指点打勾交接变化，笔奏能舍魔术成就尽潇洒，不见当秋千人并到荆州上刻画，烟坠成万岁千载人生花，聊一手笔写遍